Hello and welcome to today's Makino Experience Center event. My name is John Einberger. I'm the product line manager for horizontal machining centers here at Makino. One piece of housekeeping to get out of the way up front before we get started. What we'd like to do is get questions from you, comments from you, things that we can have as far as a two-way dialogue. The way that you can do that today, when you look at the screen that you're on right now, up in the upper right-hand corner where I have it circled, the chat function. You can use that to input questions. We've got monitors here in the room. We'll see those real time. And at the end of the presentation, we'll circle back and answer any questions that you might have. So today's topic, 5 outstanding features of the Makino a51nx and a61nx horizontal machining centers. A little bit of background about the Makino NX series horizontal machining centers. It starts from a size standpoint with the a51nx 400 millimeter pallet, Cat 40 class spindle, all the way up to its much bigger brother, the a120nx 1000 millimeter square pallet, Cat 50 size spindle. The features that I'm going to talk about really encompass that entire range of machines. The NX series of machines, very common from a design standpoint. So again, what I talk about today encompasses that entire range. But our focal point, as far as the details that we get into, are going to be around the two Cat 40 offerings, the a51nx and the a61nx. Looking at a little bit more detail on those two machines, the a51nx, as I had mentioned, is 400 millimeter pallet. The a61nx, its bigger brother, 500 millimeter pallet. Both horizontal machining centers, both standard with pallet changer as you would expect in this class of machine. Both of these share the same Cat 40 class spindles, and by Cat 40 class, Cat 40 as one alternative for the spindle interface, HSK A63 as the option. They share the same family architecture, which means same kinematic design, the same spindles, the same tool changer. A lot of commonality between the products, including the Makino Pro 6 control. So let's start out with the first of the 5 outstanding features, really the basis of the machine, the casting and the axis structure. So if we take this machine, look at the bed casting, tip it up on its side, the first point I'd like to talk about, true 3-point level. By true 3-point level, those points that are highlighted in yellow behind me are the only points that have any influence as to the level of the machine relative to its install site. All of the mechanical elements of the machine are held in alignment to each other by a very rigid, very thick bed casting, allowing very easy use for the customer. Ease of use can be defined in a number of ways. First and foremost, it reduces the foundation cost and complexity that the machine needs to sit on. We do have foundation drawings for the machine, but in looking at the foundation drawings, what you'll see is the main focal area is going to be where those 3 points actually touch the ground. We want those on one contiguous piece of concrete, adequate strength in the concrete, but other than that, the install site is very forgiving. It expedites installation of the machine. By that I mean when our service engineer comes in to install the machine at your site, they don't spend very much time leveling the machine, since all of the elements of the machine to the other elements of that same machine are all held in very tight relationship due to the assembly process and that outstandingly rigid bed casting. So in simple terms, they level the machine and move on to the next step of the installation process. As I mentioned, that bed casting, being highly rigid, establishes and maintains all the critical machine geometries. So the biggest takeaway from a long-term perspective, no periodic re-leveling of the machine is required, so no maintenance required from that aspect. One thing to be mindful of in the competitive marketplace, a very common competitor of ours, 400 millimeter class machine, so not a very large platform, billed as a 3-point leveled machine. What I'm going to show you is some data from their installation manual, their terminology, but bear it in mind that everything that's billed as a 3-point level machine may or may not be. So on the competitor side, those are the 3 leveling points. Their terminology, in addition to that, they have 2 sag supports. They also have 2 additional supports, one on the pallet changer side and one on the Z-axis, what they call twist supports. So in this case, machine build is a 3-point level. In reality, 7 total touch points between that machine and the floor that have direct influence over the alignment of the machine tool. Moving forward, taking that bed casting, dropping it back down, and bringing the column into place. A hallmark feature of Makino going back to the mid-1990s, the stepped bed and column design. This is something that Makino pioneered in the model A55E machine, 4 generations older than where we're sitting today, but it's proven to be so effective that we continue to use this today. So by step bed column design, what I mean in looking at the side view of the machine, a very pronounced difference in height of the frontmost linear motion guide for the column relative to the rearmost linear motion guide. Very significant height difference between the two. And what does that mean from the standpoint of the user experience? First and foremost, it directs the spindle forces that are achieved during the cut in through the spindle, through the column, into the bed casting, and ultimately into the foundation using a very short force path. The result of that, minimization of structural deflection in that overall assembly. As that machine is used for high metal removal rate machining, you'll certainly experience that. Full utilization of the Y stroke of the machine. So not only heavy duty machining when that spindle is down close to the pallet top, but in the more challenging case as that spindle is elevated up in the Y stroke, still the ability due to the rigidity of the platform to do heavy metal removal. It also, as another benefit, improves the X-axis responsiveness of the machine. So again, in that view that I have behind me, that column as it moves into and out of the screen for an X-axis move, we're translating moving mass from the column and instead making it stationary mass that becomes part of the bed casting. So we're accelerating and decelerating less mass and making that X-axis move. It makes the machine all that much more responsive, all that much more accurate and repeatable as far as that movement. One thing I want to touch on, another benefit of this, I talked about the rigidity increase in the machine. That translates very directly into improved life of the perishable tooling. This is data that we are able to run through a customer relationship on a competing brand of machine. And I'll point out that the competing brand of machine also uses the step bed and column design. Makino data is in orange. Competing brand of machine, which looks a lot like the Makino, is in blue. What you're seeing behind me is tool wear. So this is tool wear, number of minutes in the cut, the amount of measured flank wear using a instrument grade microscope to do the test cut, gauge the wear, continue the test cut, gauge the wear on an iterative basis. A very significant divergence in tool wear of the competitor machine relative to tool wear on the Makino. Upside to the customer, improved tool life, lower operating costs over time. Resulting kinematic of the machine looks like what you see here behind me. So the key point, the key takeaway on that first outstanding feature of the Makino product, the bed and the column design results in outstanding rigidity, maximizing productivity, maximizing metal removal rate, while also minimizing the perishable tool cost. So moving forward, way cover system. Often an area from a maintenance perspective on a machine that can be very consumptive of resources, very consumptive of operating costs. The solution that Makino continues to bring to the table is very simple and as a result, very reliable. What you see highlighted in blue are the Z-axis way covers, common design for all the NX series machines. They're single piece. Makino brought this to market in the predecessor to the a51 and 61nx, the a51 and the a61 that debuted around the 2001 timeframe. So again, a long-standing feature of Makino that continues to be very economical and very reliable from the customer experience perspective. The thing that we had to do is be very creative and think about the covers not as an afterthought, but really as part of the holistic design of the machine. The areas that I circled in red, those were developed to allow those Z-axis covers to slide underneath that column area of the bed casting as the Z-axis moves in towards the spindle. Again, a holistic design approach, building the forethought as to how are we going to accommodate these single piece covers right into the base element design of the machine. In addition to that, single piece cover on the a51nx in the x-axis, two piece cover for the a61nx. Again, very, very simple design. Part of the overall design of the machine, the use of the single piece cover, very low failure rate from the standpoint of any maintenance required. So the key point on the way covers, by designing the way covers not as an afterthought, but as an integral element of the machine, the result, single piece covers, and net result to the customer, significantly lower operating costs over time, improved uptime of the equipment. Third point, active thermal management. What we see in the competitive marketplace very often with competing brand machines is reactive thermal management. We see very overt advertising around basically with a message, things happen from a thermal perspective, we monitor them, we offset accordingly. We have thermally symmetric designs that allows us to do that. That is what I would term passive thermal management. Makino takes a very different approach. We take what I'm going to term active thermal management as part of our mainstay design. We use the bed casting temperature, the biggest thermal mass in the machine, as the reference point to feed into our temperature control unit. That temperature control unit is going to output cooling oil relative to the base casting temperature of the machine within a plus or minus 2 degrees centigrade window. It's going to take that output of oil used for cooling purposes only and feed it to the spindle, to the ball screws, and in the case of the a51nx, a61nx, the direct drive B-axis unit. Around the spindle periphery, take the heat out of the equation, through the ball screws into the motor-driven side, pull that heat out of the equation, and similar to the spindle around the B-axis, pull the heat of that integral drive motor out of the equation. The whole premise with active thermal management is instead of allowing thermal events to happen, monitoring what the result is and then offsetting accordingly, with the active approach, we keep the thermal event from happening, period. So instead of reacting to it after the fact, we eliminate it right up front. A little bit of empirical data. This is thermal imagery data looking at the X-axis drive unit on an a51nx, a machine equipped, as an example, with a core-cooled ball screws. We started the machine dead cold, ran a production program for a period of time, looked at the thermal imagery 2 hours in, machine in continuous operation, very, very little heat gain from the dead cold machine. 4 hours in, very consistent. 6 hours in, very consistent, very thermally stable approach, again with that methodology of actively removing the heat from the equation. Through a customer relationship, we are allowed access to a machine that's billed as coming standard with scales. They allow the thermal event to happen and then attempt to accommodate for it after the fact, running exactly the same program, exactly the same conditions, dead cold. 2 hours in, you'll notice a pretty significant amount of heat gain relative to what's happening on the Makino side. 4 hours in, a significant increase in the heat gain relative to its own geometry at 2 hours, even more so at 6 hours. So a lot of events happening here over the course of that 6 hour production run that now need to be accommodated for from the standpoint of trying to figure out what the effect is and compensating accordingly. The premise that I'll say is that we all know that machining processes are very diverse. Some processes have a significant amount of axis movement in X or Y, maybe not so much in Z. The next process could be exactly inverse of that. So if you have non-symmetrical heat loading, which I think is a reasonable expectation, the ability to compensate for that and to try to get the resultant bend and twist out of that overall assembly that's affected by heat in some areas, but maybe not so much in other areas, can become very challenging, very daunting. One of the upsides that a customer will experience in using the Makino approach, very, very tight accuracy, very, very tight repeatability, even without the use of scales. Makino does offer glass scales as an option on the machine, To be very honest, the take rate on that is relatively low. There are a few industries, optics manufacturers, manufacturers of semiconductor manufacturing equipment, where getting plus or minus a half a micron increase means something to them. The majority of customers, the machine without scales, that plus minus 2.5 micron accuracy, the plus minus 1.5 micron repeatability is very adequate to ensure overall process capability. So the key takeaway point, by actively removing the heat from the machine, the customer enjoys the direct benefits of sustained dynamic accuracy. Another upside, increase in reliability, since we're not heat soaking moving elements such as ball screws on that piece of equipment. Moving forward, the tool changer system. This is a part of the machine that's very actively used. Not uncommon in the production world to see over 2 million tool changes per year. Direct data received from customers of ours. So I want to focus on a couple of elements of the tool changer system, whether it has the ring style magazine on the machine that we see here or the bigger matrix. Let's focus on the actual tool change itself, what's happening with this S-arm. The Makino design uses a cam box that drives all of the mechanisms, all of the actions, all of the motions that are used to physically change that tool from the ready position into the spindle and vice versa. So with the one drive motor coming into the cam box, with the cam box responsible for all those motions, very easy from the standpoint of any diagnostic that may have to be done, but more importantly, very high level of reliability, minimization of external moving parts. I want to focus on one particular detail of the tool change mechanism itself, just as an example to the attention that Makino pays to what really affects the reliability of an overall system such as this. Something as simple as the tool keepers that ensure that the tools stay in both sides of the S-arm during the physical tool change. As that S-arm comes into place and it comes over the tool in the spindle and it comes up over the tool that's in the ready position, that element needs to be spring-loaded, very common design. So that allows that keeper to snap out of the way, snap over the tool, but that's where we start to change. As we progress with the tool change, as we start to pull those two tools out, one from the spindle, one from the ready position, spin them 180 and reinsert them back in, this element becomes collet locked. So we want to be able to change tools fast, but we need to do so reliably, and we also need to do so in a way that doesn't allow that tool to rock inside of the S-arm. That minimizes any possibility of damage to the spindle taper, minimizes the possibility of any damage to the tool taper coming in, coming out. Furthermore, that type of element will be auto-lubed on the Makino as standard. So the standard grease lubrication system that hits the ball screws, the linear motion guides, other moving elements in the tool magazine, also is fed through the arm and auto-lubes even small details such as this. Again, with a really an upshot in reliability and taking yet another maintenance task off the plate of your maintenance personnel. Moving forward in the ATC system, the ATC shutter door, again, something that would seem to be somewhat of a small detail, but in that environment where we see up to 2 million tool changes a year, that's 4 million cycles of that shutter door either opening or closing. The majority of machines in the competitive marketplace are going to use a pneumatic cylinder to open that door, same pneumatic cylinder on the other side of the stroke to close that door. You're going to see the door move and bounce off the cushion both on the opening side and on the closing side. Makino takes a very different approach. Some might look at this at the onset and say, well, that kind of seems like overkill, the use of a servo motor and a ball screw to open and close that shutter door. But from the standpoint of sustained reliability, it's very easy on the mechanism to have such a controlled motion. The other upshot, since this now becomes in essence a programmable axis, we have the ability to look at the tool data, the length of the tool coming in, the length of the tool coming out, and the longer of the two, open that door only far enough to execute that tool change. It minimizes the intrusion of chips, coolant, matter from the machining area into the tool magazine. So another upshot of that design. So the key point, key takeaway, we know that the tool changers are a highly stressed area of the machine. We know that the cycle time of them is very important to the overall machining process efficiency. By focusing not only on speed, but also on reliability, we bring that value forward to the customer. Last point today, spindle offerings. The machine that we're talking about with the 51nx and the 61nx, they really serve a whole variety of different applications, everything from automotive to medical to die mold and other components in between. We have a number of spindle offerings that are really tailored at the specific use of the machine. Let's focus first and foremost on automotive components, industrial equipment. Very common in this area for usage is our standard 14,000 RPM spindle. 50 horsepower certainly brings a lot of power to the equation, but also at 223 foot-pounds brings a lot of torque to the equation. That instantaneous peak torque is very critical from the standpoint of spindle acceleration, spindle deceleration, and think about in your production environment how advantageous that is every time you rigid tap a hole where you have 4 ACDEC events associated with that spindle for every hole that you create. So again, a lot of torque, a lot of peak, minimization of cycle time. Standard interface is Cat 40, the option on the machine, HSK A63. Remember the discussion that we had about tool life? One of the elements that we build into the spindle, a very large spindle bearing ID. Okay, how does that relate to anything? The ID of that bearing is going to be the same as the outer diameter, the OD of the spindle shaft, directly related to the stiffness of the spindle shaft, directly related to lack of flexure. Think about that tool being highly radially loaded, very stiff spindle shaft, minimization of flexure. We certainly see that result also permeated through an increase in tool life. One of the metrics that we track very, very closely here at Makino are shipment of spare parts. It's an excellent indicator of spindle longevity and reliability when we look at the consumption of replacement spindles relative to the install base. Let's look for a moment at the array of Makino machines that use that standard 14K spindle. Everything from our current a51nx, our current a61nx that we're talking about today, their 5-axis brother, the a500Z, and the predecessor machines, the a51 and a61, they all use the same spindle part numbers. What we see here in green from the years 2016 through the end of 2021 is on a year-over-year basis, the number of machines installed in North America and South America, our territory, that use that part number spindle, peaking again at the end of 2021 over 3,200 machines. Now as we overlay in the number of spindle shipments that service that population in red, you can see a very small percentage of those machines, some of them installed as early as 2005, that use that part number spindle. Very good indicator from the standpoint of the longevity of the spindle when the spindle shipments are such a small percentage of the overall install base. Bear in mind also, a spindle shipment can be for whatever reason. It could be to repair a spindle that's been crashed. It can be to replace a spindle that just is flat worn out. Again, bearing in mind that that machine may have been in production as early as 2005, or something that we did on our side in the manufacture of the spindle. But with that combination of data, still very small percentage of the install base in every year from 2016 tracking through the last complete year as we stand here today. Moving forward off of the 14K spindle, again, these machines service a number of other arenas, aerostructural components, medical, the die mold industry. We offer an optional 20,000 RPM spindle for customers that need that level of spindle speed. Maybe they're running small tools, want to run as high of a surface footage as they can from a metal removal rate standpoint. That optional 20,000 RPM is a very good fit in those type environments. 40 horsepower, 95 foot-pounds of torque, but more importantly, the sustained max horsepower range stretching from 6,000 all the way up to 13,000 RPM. So a very broad range of maximum horsepower where you can really get at it, really do that high metal removal rate while staying within that horsepower band of the machine. So a very good alternative. Again, think about this as aerostructural, aluminum machining, medical, and die mold. So the key takeaway point on the spindles: the spindle systems are designed to provide not only high performance outputs, but with an utmost of reliability. So to summarize the outstanding features: the casting and the axis structure of the machine, the way cover system, active thermal management, the tool changer system, and the spindle offerings, we hope that those add up to profit for you. So thank you for your time and attention today. What we're going to do now is turn it over to address your questions that have come in during the course of today's presentation.
Okay, we do have two questions that have come in today, both of them pertaining to automation. The first question asks, if I were to start out with a standalone a61nx, would it be possible to integrate that into your pallet handling system? And the answer, very easy answer, yes. The machine is designed that the front end sheet metal on the machine can be modified rather easily to physically plug that machine into the product that we call the MMC2. That's our pallet handling system. Easy to do from a mechanical standpoint. And also the provisions are there on the control side to tie that machine into the cell control for the MMC2, what we call MASA5. So something that happens on a very frequent basis, and again, designed to be integrated into that automated system from a pallet handling standpoint at any point in time in its life. And the other question, as I had mentioned, also pertains to automation. Can your machines be used in a part load scenario? And by part load scenario, I'm going to assume that means a robot directly loading parts onto the machine instead of the pallet handling. And again, the answer to that is yes. There's a variety of machine options that are designed to be easily retrofittable to the machine. Think about things like auto doors on the front side of the machine, the fixture hydraulic system that provides pneumatic and hydraulics to the work holding fixtures, fixture wash, things of that nature, robot interface, again, all easily added to the machine after the fact. So hopefully that answers the questions. If you have any more questions or want to have further dialogue or a one-on-one discussion, feel free to reach out to me directly at john.einberger@makino.com or contact your Makino salesperson and they can set up a meeting. Again, we appreciate your time and thank you.